In this episode, we focus on a skill that helps you make smart security decisions before problems show up in the real world, prioritizing application risks using threat modeling and abuse case thinking. Beginners often hear the word threat and imagine a specific hacker or a specific exploit. But in application security, the challenge is broader and more practical. You are trying to figure out what could go wrong, how it could go wrong, and which problems matter most so you can spend time and effort where it actually reduces risk. If you try to protect everything equally, you end up protecting nothing well because attention and time are limited. Threat modeling is a structured way to reason about risks based on how an application works. And abuse cases are a way to imagine the same application from the perspective of someone trying to misuse it. Together, these approaches turn security from guessing into a disciplined process of identifying high-impact, likely problems early. The goal is not to scare you into thinking everything is dangerous, but to give you a way to sort risks into an order that makes sense. By the end, you should be able to explain what threat modeling is, what an abuse case is, and how they help teams focus on the most important application security issues. A helpful first step is to clarify what we mean by application risk, because risk is not the same as a vulnerability, and it is not the same as a threat. A vulnerability is a weakness that could be exploited, like an input that is not validated or an access check that is missing. A threat is a potential cause of harm, like an attacker trying to steal data or disrupt a service. Risk combines the two, along with impact and likelihood, meaning it is the probability and consequence of something bad happening given how the system is built and used. Beginners sometimes treat every vulnerability as equally urgent, but a small weakness in a low-value feature is not the same as a moderate weakness in a feature that handles sensitive data. Prioritization is the act of deciding what to fix first, what to fix next, and what might be acceptable temporarily based on real-world consequences. Threat modeling and abuse case thinking help you prioritize by making you look at the system as a set of assets, entry points, trust boundaries, and behaviors rather than as a random collection of code. This is why they are so valuable. They create a map of risk that can be discussed and improved. Without that map, decisions become reactive, political, or based on whoever speaks loudest. Threat modeling is best understood as a structured conversation about how an application could be attacked or could fail in ways that cause harm. It usually begins by describing the application at a high level, including the main components and how data moves between them. You do not need advanced diagrams to understand the core idea, because the important part is identifying where data enters, where it is processed, where it is stored, and where it goes next. Threat modeling then asks what could go wrong at each step, especially at points where trust changes, such as when data comes from outside the system or when a user request reaches a privileged function. The purpose is to identify plausible threats and to connect them to specific controls or design choices that reduce them. Beginners should notice that threat modeling is not about predicting the future perfectly. It is about reducing uncertainty by thinking systematically. It is also not a one-time event, because systems evolve and new features change the map of risk. When teams do threat modeling well, they avoid building fragile features that later require emergency fixes. Instead, they build with a clear understanding of what must be protected and where protections should be strongest. To make threat modeling practical, it helps to focus on assets first, because assets determine impact. An asset is anything valuable that the application handles or enables, such as user identity, personal data, financial transactions, administrative functions, or the availability of a service. Once you name the assets, you can ask what harm would occur if an asset were exposed, altered, or made unavailable. That harm might be privacy damage, financial loss, safety issues, or the loss of trust that makes users stop using the service. Beginners sometimes think security is about protecting servers, but in reality, you are protecting outcomes, and assets are the link between technical behavior and real-world consequences. When you tie threats to assets, prioritization becomes clearer because you can say, this problem affects a critical asset, so it deserves attention even if it is harder to fix. Conversely, a threat that targets a low-impact asset may be lower priority, especially if resources are limited. Asset focus also prevents over-engineering, because you can avoid applying the strongest controls everywhere when only some parts of the system truly require them. This is a key step in avoiding security work that is busy but not effective. After assets, you consider entry points and trust boundaries, because that is where likelihood often increases. Entry points are places where the application accepts input, such as web forms, application programming interfaces, file uploads, or integrations with other systems. Trust boundaries are the places where something less trusted interacts with something more trusted, such as a public request reaching internal logic or a normal user request reaching administrative functions. Threat modeling looks at these points because they are common paths for misuse, mistakes, and exploitation. Beginners should understand that systems often fail at boundaries because boundaries are where assumptions collide, like assuming input is well-formed or assuming an identity claim is valid. By listing entry points, you force yourself to think about how someone could interact with the application in ways you did not intend. By naming trust boundaries, you identify where authentication, authorization, and validation must be strongest. Likelihood tends to be higher at entry points because attackers can reach them repeatedly and cheaply, and because mistakes in handling input are common. Prioritization becomes easier when you can say, this feature is a high-exposure entry point that touches sensitive assets, so threats here deserve priority. Abuse case thinking complements threat modeling by flipping the framing from what the system is supposed to do to how someone could use it incorrectly on purpose. A normal use case describes intended behavior, like a user logs in, views data, and performs actions allowed by their role. An abuse case asks, what if someone tries to log in as someone else? What if they try to access data they should not see? Or what if they try to manipulate the workflow to get an outcome they are not entitled to? This is not about imagining a supervillain with unlimited powers. It is about realistic misuse patterns that follow from how the feature works. Beginners often struggle to think like an attacker, but abuse cases give you a straightforward way to start. Take each normal use case and ask how it could be bent, bypassed, or abused. This approach is especially useful for business logic issues, where the problem is not a technical bug like a crash, but a misuse of the rules of the application. For example, a workflow might allow a refund, a discount, or a privilege change, and an abuse case asks how those steps could be manipulated. Abuse case thinking helps you identify risks that might not show up in generic vulnerability lists. A powerful part of abuse case thinking is that it forces you to consider motivations and incentives, because attackers often target features that create value. If a feature can move money, grant access, change identity details, or reveal sensitive information, it is a natural target for misuse. Even if the code is technically clean, the feature may still be risky if the workflow allows unintended outcomes. Beginners should see that not all threats involve breaking in. Sometimes the threat is someone using the system as designed, but in a way the designers did not anticipate. Abuse cases also highlight where the application relies on trust in user behavior, like assuming people will not try the same action repeatedly or will not attempt to guess identifiers. By writing down abuse cases, you can ask what controls prevent them, such as rate limiting, stronger verification for sensitive actions, or stricter access checks. You can also ask what detection signals might indicate abuse, which ties the work back to security operations. When abuse cases are clear, teams can design controls that are targeted and practical rather than vague and heavy. This is a key advantage of abuse case thinking. It keeps security grounded in how people actually behave. Prioritization happens when you combine impact and likelihood into a practical ordering, and both threat modeling and abuse cases provide inputs for that decision. Impact comes from assets and business consequences, while likelihood comes from exposure, complexity, and the ease with which a behavior could be triggered. For example, a high-impact threat that requires extremely rare conditions might be lower priority than a medium-impact threat that can be triggered easily and repeatedly through a public interface. Beginners should not get stuck trying to calculate perfect numbers, because the goal is to make relative judgments that guide action. Another factor is detectability, meaning how likely you are to notice the problem if it happens, because risks that are hard to detect can cause long-term damage before they are discovered. When you consider detectability, you may prioritize controls that improve visibility as well as controls that prevent misuse. Threat modeling often reveals blind spots, such as parts of the system where actions are not logged or where identity is not verified strongly. Abuse cases reveal where the workflow could be manipulated quietly, such as actions that change state without obvious alarms. Together, they help you choose priorities that reduce both the chance of harm and the time to discover harm. Another beginner-friendly way to think about prioritization is to focus on high-risk patterns rather than on every possible detail. Patterns like weak authentication, missing authorization, insecure data handling, and unsafe integration boundaries tend to create large risks because they affect many features and many assets. Threat modeling helps you see where those patterns exist in your architecture, such as where identity is asserted, where access checks occur, and where data is stored or transmitted. Abuse cases help you see how those patterns might be exploited or misused in concrete ways, such as pretending to be another user or skipping a verification step. Prioritizing pattern-level issues can be efficient because fixing one pattern can reduce risk across multiple features. Beginners should understand that this is part of how security scales. You look for root causes and systemic weaknesses, not just one-off bugs. That does not mean you ignore specific issues, but it means you try to identify the few design choices that create many downstream risks. When you focus on patterns, you also improve consistency because teams learn what good design looks like and apply it repeatedly. This reduces the need for constant firefighting later. It is also important to address common misconceptions that can derail threat modeling and abuse case thinking. One misconception is that threat modeling is only for large systems, but even small applications benefit because the process is mainly about clarity and early decisions. Another misconception is that threat modeling must be done by security specialists only, but the best results usually happen when developers, designers, and product stakeholders participate because they understand the feature goals and workflows. A third misconception is that abuse cases are about being paranoid, but the point is not paranoia, it is realism, because systems exist in the real world where people make mistakes and some people intentionally misuse. Beginners should also avoid the trap of making threat models so detailed that they become unmanageable, because the purpose is to guide priorities, not to create a perfect encyclopedia. A good threat model captures the main components, main data flows, main trust boundaries, and the most plausible threats tied to important assets. Abuse cases should focus on key workflows that create value or control, not on obscure hypotheticals that nobody can act on. When you keep the process practical, it becomes repeatable and useful, which is the real goal. Threat modeling and abuse case thinking also connect naturally to design reviews and security requirements, because they generate concrete guidance rather than abstract warnings. Threats and abuse cases can be translated into requirements, such as requiring stronger verification for sensitive actions or requiring clear authorization checks at certain boundaries. They can also guide design improvements, like isolating a critical component, reducing unnecessary exposure of internal services, or simplifying workflows to reduce manipulation opportunities. Beginners should notice that these activities work best when they are done early, because the best time to change a design is before it is locked in. They also support testing strategy later, because the team can test controls against the highest priority abuse cases rather than testing randomly. This does not require deep technical tools to understand. It is a simple idea of aligning testing with the most important risks. When teams use threat modeling and abuse cases to guide requirements, design, and testing, security becomes coherent rather than scattered. The process produces a shared understanding of why certain controls exist, which improves long-term maintenance because future developers can see the reasoning. This is how security becomes a property of the system rather than a set of last-minute patches. When you step back, prioritizing application risks with threat modeling and abuse case thinking is about turning security into a structured, collaborative decision process. Threat modeling gives you a way to map the application, identify assets, locate entry points and trust boundaries, and reason about plausible threats tied to real consequences. Abuse case thinking gives you a way to imagine realistic misuse of normal workflows, especially business logic abuse that might not show up in generic bug lists. Together, they help you rank risks by impact, likelihood, and detectability so you can focus effort where it reduces harm the most. They also produce practical outputs that can shape requirements, design choices, and testing priorities without becoming tied to any one tool or vendor. For a beginner, the most important takeaway is that security work is most effective when it is intentional, and these methods give you a way to be intentional instead of reactive. When you can explain the highest risk paths through an application and the most plausible ways they could be abused, you can guide teams toward controls that matter and away from busy work that only looks like security. That is the heart of good application risk prioritization.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit DailyCyber.News.